So we're going to start our discussion with the server portion of the folder application. And as I mentioned, in a Spring project, it's typically done in a very canonicalized way. You typically have something called an application, which is essentially the main entry point into the application. You can use applications to be either services, monolithic applications, or microservices. Right here, we're doing basically a monolithic application, but we could always split it up if we had the need to, and it's not hard. In this particular case, you can see we have a class called FolderApplication, which we've annotated to be a Spring Boot application. And that just means that it can use auto configuration, component scanning, dependency injection, all the good stuff that Spring provides you. We tell it where we want to scan to find dependencies, and we basically say, look in the folders package, which is the top level package. So kind of grab everything we need. And I could narrow that down if I needed to on a class by class basis. This just makes it easier to manage this stuff. And then down here, we go and get access to something that's also in resources, which is the application's property file. So we call the program, the name of the application is going to be folder, kind of boring, but that's what it is. And then we also tell it what port number we want the server to listen on, which in our case is 8081. And we could change that without having to recompile the code. That's kind of the beauty of doing things this way. The main entry point is something that is needed for Spring to get up and running. You can see that we parse the arguments using our options singleton. We can decide various option related issues. I don't think we set any here, but we could. We can turn on debugging, for example. And then we also launch the application, and we basically say, FolderApplication.class, Spring, please use this as the entry point to start running everything. And it goes off and it does the dependency injection, all the dependency management, and all the other generation of things that need to be deferred until startup time. And so when the program begins to run, this is the entry point that makes everything start to happen. One of the most interesting things that starts up is this entity called the controller. In this case, we call it the folder controller. And what it basically does is it mediates between the world of HTTP requests like GET requests or POST requests or PUT requests and so on, and the wonderful world of Java with Java native types like string and integer and list, map, and so on and so forth. And you'll see down here that to make it work like this, we use an annotation called the REST controller annotation. And that basically allows us to be able to treat these endpoint method handlers as ways for Spring to automatically convert from incoming HTTP requests, like a GET request, into the appropriate call to the endpoint handler method that we'll take a look at. And we also do something here, we don't have to do this, but we just say, I want the URLs that are sent over here to include a /folders prefix. So that if we had multiple controllers, we could differentiate amongst them. This is something that's very common in most Spring applications. You have a field in the controller that's auto-wired to the service. So in this case, we're going to have the folder controller forwarding to the folder service. We'll look at that. That's where the business logic goes. And then we've got a bunch of these endpoint handler methods. And you can see each of these endpoint handler methods has something called get mapping, because they're all get requests. And we take a path, which in this case is going to be what's passed in here is the root dir plus the name of the method that is going to be encoded in the URI. So this is basically the request name or the request ID portion of the URI, which in this case for search will be search folder. And you'll see for each of these methods, we do the same basic thing. We have /get documents. We have the /count lines. We have /create folder, and so on and so forth. And so this is the way that Spring knows how to connect the incoming HTTP requests that are being sent at the low level using things like servlets and receive with servlets and HTTP request objects and HTTP response objects and so on. And these nice Java hook methods that are filled in. Now you'll see here that in addition to the get mapping annotation, there's also annotations provided on the various parameters. Not all of these are necessary. Might be considered a good style to put them in there, but they're not all required. Things like path variable, that's so that is what can be used here to indicate what particular entity that we want, what database table, for example, you might want to get access to. In this case, this is searching to see if a word exists or how often the word exists within the recursively structured folder hierarchy. And so you pass in the word, and then we also pass in a Boolean indicating whether we want to do the searching sequentially or concurrently. And if you take a look at the results here, you can generally see that if you run things concurrently, it takes less time than if you run them sequentially. So just something to be aware of. Concurrency, in this case, parallel streams, is a win. Now, what we always do here is these endpoint handler methods really don't do anything other than turn around and forward to the same method name on the service that was auto-wired into our particular controller. So we're going to forward to the folder service search word method, passing in the root dir, the word, and the concurrent Boolean flag. And this is intentional. That way, the service doesn't have to know anything whatsoever about this HTTP mapping stuff. It can be entirely oblivious to those details. It just is good old Java code doing good old Java business logic. So we have a way to search for a word. We have a way to get a document. So what we do here is we will search in our recursively structured folder hierarchy for all documents that contain the word. So it'll basically give you back a list of entries that correspond to the documents that we have. And I'll show you how this works. It's really super cool. So that's how we get back the documents that match words. You can also count the number of entities or entries that we have here, folders, documents. It just counts them all. We also have one that counts the number of lines of all these things, and all this stuff either works concurrently or in parallel or sequentially. And then a final method that I probably should move earlier is create folder. And this particular method is useful because you can use that on the client side to download the entire contents of the repository and then do your operations locally off essentially a cached version of that. And you can see in all these cases, we have a little bit of annotation going on, but we're basically returning very powerful composite types here. In fact, this durant is really the root of an entire hierarchy of an in-memory data structure that contains all the entries in that file system. Okay, so that's basically what the controller does. And these annotations are needed. In some cases, they're actually needed. In other cases, they're just helpful to have around. Typically, whenever you pass something that's going to be, say, like a list of something, like a list of strings or a list of integers, you need to use a request param annotation. If you start passing things that are multi-part structures, such as images and so on, then you need to use the request part annotation. And in fact, in your programming assignment that you've got coming up, there'll be a situation where you'll be passing around multi-part objects as parameters, and you need to use the request part annotation to do that. I haven't quite figured out how to integrate request part into this example yet, but when I do, that'll be showcased there. But it's pretty simple. So let's go take a quick look at the service. So this is really the business logic. This is the implementation file. This is going to be using either concurrent or rather parallel or sequential Java streams to do all the work. And you can see down here, we have a create folder method that takes a string, which is basically the directory we want to get in our rooted file system, and whether we want to run concurrently. And it just turns around and forwards to a method called create folder, which is part of this class called file ops for file operations that's shared between the client and the server, because both the client and the server use this code depending on what you're doing. So very quickly, here's what this code does. This code is going to go ahead and get the root folder file from the root of the hierarchy. And all this does is it just goes ahead and basically makes a new file that will load in the top level directory. In this case, it's what's called works. So we're going to go load works. And then everything from that is done recursively. So we get ourselves a directory that contains the initialized folder, and then henceforth we can do all the other stuff in other ways. Down here we have a couple of other methods here that we use. For example, let's go back to folder service. So that's how you make yourself a directory that contains the initialized folder with all the contents, and it basically streams the whole thing out in a very cool way using splitterators, as we'll see briefly. Then there's another method called count entries, where we go ahead and we create ourselves a folder. So now we've got all the contents, and then we go ahead and we count the entries. So after we've created this folder structure, we then go ahead and use the stream support.stream method along with the root folder splitterator to basically create a stream of all the contents in that folder. And then we just count the number of items that there were found there. So very simple use of streams. This is some really cool stuff. I'm going to just briefly talk about the data model. This is very, very, very cool use of Spring features. So the root of the recursive structure is called a durant, and that is by design. That's sort of a pun on the struct of the same name in C. Recursively structured folder file systems or directory structures in Linux and other versions of Unix and so on use a durant struct. And so we're kind of punning off of that. And durant basically keeps track of the path, this number of entries that it has in this folder. And this is basically a super class. And so it's the root of a document class and a folder class. As you might expect, a document contains the name, of course, which it inherits from the durant. And it also, of course, contains the contents of the file. And a folder contains a bunch of either subfolders, if it's got recursively nested structure, and or documents. So a folder is basically a composite, and durant is the root of all this stuff. And we'll take a little bit of a look at some of this. This is more complicated than I want to get into right now for the discussions about Spring and making these calls that are remote method invocations. But this is the key thing that makes all this work. We have this very cool annotation here called Json type info. And basically, it tells Json, which is the encoding mechanism we have to encode JSON, to essentially treat these as richly typed objects and to be able to essentially do deep copies of them when it passes them across the network. And that is just the coolest thing ever, because it means that we have almost no work to do to encode and decode the contents of this very rich recursive data structure. For your assignment 2, you don't have a data structure that's quite as complicated as this, although it does have some interesting aspects as well. But this is just demonstrating how powerful the annotation mechanisms are in Spring to be able to encode these recursively structured composite objects. So that's basically what durants are. They're directory objects that are either going to be documents or folders, and then the whole thing is built up recursively. So we come back over here, and you see we just count the entries there. There's also another really cool thing that we've got with create folder, which I should look at briefly. What we're basically doing is we're calling the from directory structure. And what from directory does is it takes the root into a composite recursively defined data structure, the directory entry. And it goes and it asks that particular root, give me a list of all the files. Remember, a file can either be a document or a folder in the type of world we're working in here in Java. So we take the array of files, and then we convert that into a list of files. And then we use the list of files together with something called a splitterator. And I'll just briefly point you to this. We won't spend a lot of time on it. It is absolutely the super coolest thing ever. And that allows us to be able to recursively traverse through the contents of the directory entity here. And basically, we use this iterator mechanism, which creates a breadth first search iterator. And the breadth first search iterator knows how to walk through every element in the recursively defined directory structure and basically stream it back one element at a time. So again, super cool, very powerful stuff. There's also another method called count lines where we make a directory and then we just go ahead and count the lines. The count lines thing is fun. We go through and we basically take ourselves the root folder, turn it into a stream of all the entries at that point. We only allow items that are documents to be considered here. We're going to skip over anything that's a folder because there's no sense in counting the lines in a folder. We want to count lines in a document. And all the documents are represented, of course, they're flattened here. And once we get the documents, then we call this method called split as stream, passing in new lines. And what split as stream does is it compiles that new line regular expression and then splits the document's contents by new lines. And so then we end up essentially with we end up with a stream of strings, which are the contents of the file. And then we just count how many strings there were, which is an indication of how many new lines there are. So of course, there are probably faster and more efficient ways to do this. This is just a fun way to show how you can split things up with streams in various cool ways. And then there's also the search word mechanism where we get ourselves a folder and then we call count word matches. And count word matches, again, can either run sequentially or in parallel. Not surprisingly, the parallel versions run a lot faster than the sequential versions. And what that does is that goes through the documents, and for each document, it goes ahead and splits the document up into words, and then only considers words that are equal to what we're looking for, and we just count the number of times we get a match. And then we take all those counts and we sum them together to get the count of the number of times the words we're looking for appeared in the entire directory structure. And then I think there's one more method here, get documents. Get documents is also kind of fun. What get documents does is it goes ahead and takes a look at all the contents of our recursively structured directory on the server side, only looks at documents, and then it goes and it searches in the document to see if there's a match of the word. And if so, we let that document name continue. So we're only going to take the documents. We're only going to take documents that have a match. And again, you can see how we use filter to only consider documents. Then again, we use filter to only consider documents that contain the words. And we end up basically with a list of these documents. And that's what gets passed back to the client in this case. So those essentially are the key methods on the server side. As you can see here, we have a folder application, which is kind of the main entry point. We have a controller, which is going to take requests from a client. And then we have the folder service, which is the business logic that does the work. And again, I'll in other upcoming videos, I'll be talking a bit more detail about how these different things work, but I just wanted you to see the server side implementation. And your assignment 2 implementation will look quite a bit like this structurally. You'll have an application, which we provide for you. You have a controller that you have to fill in the annotations and a few other aspects of the implementation. And then we have the implementation part, which is the service. In your case, it's the transform service. I think it's called main service or something like that. And it's responsible for then vectoring the work off to do the transforms. Okay, so that's the overview of the server.